You're going to have to bear with me with this next section, routing fundamentals, because we might have to do it a bit reverse Uno, a bit back to front. And what I mean by that is I'm going to explain things like the routing table and the forwarding table, next hops. But before I can explain those, then I'm going to have to configure like static routes or a routing protocol. And we haven't covered those, which we will cover later on in this section. But as I said, it might be a bit back to front. But saying that, what is routing? Well, routing is the process of moving data between a layer 3 network, usually they're connected by like a router or a layer 3 switch. And if we have a look at this topology, we're going to know that for any device to communicate with another device outside its directly connected subnet, so in this scenario, what I've got here, like devices A and B, if they wanted to communicate with devices C and D, they're going to have to go through the router, and the router will act as both of these devices' gateway. Now, the gateway is usually a router, and the gateway determines the next hop for the destination prefixes. So, as I was saying, for any device to communicate with another device outside its directly connected subnet, a properly configured gateway is required. So, in our scenario here, if router A wanted to communicate with, say, router C, it must set its gateway to 200.1.2 as an example. We're also going to need a routing protocol for these devices to communicate. And this can include various routing protocols, static routes, and directly connected routes. Now, if there are multiple routes for a given prefix, a single route is going to be selected as being the active route, but Junos can support multiple equal cross routes. So let's have a look at how I'm going to configure this lab. And currently I have router 1, router 2, router 3, and router 4. And I've already configured static routes and probably some OSPF here, but I haven't done anything on the actual router itself. So these will be hosts and this will be our router in the middle. Let's just open this up. Maybe I have it open already. Yeah, so VMX1, let's just do a show route. Now, a show route will show you the routes that I have and to which networks. So run show route because I need to run it from operational mode and I'm in configuration mode. Yeah, it doesn't look as though I have any of the routes configured. Let me just delete the configuration we had under the GE00 interface previously. Edit interface GE000.0. If I do a show here, it will show what configuration we have. We're just going to say delete family inet. Commit that. That will get rid of the interface routes. And now what I need to do is configure the routes over to R1, R2, R3, and R4. So if I say up to, yes, that's what I want. So I can now say set GE000.0 family inet. And when we're using inet, that means we're using IP version 4 addresses, just to reiterate that point. Family inet address of 200.1.1.2. I should be able to do this for all of them. 1 goes to 2, 2 goes to 3, and 3 goes to 4. So GE0, yeah, that looks good. 3.2, interface GE000. Yeah, and the last one is 4 on interface GE0003. Alright, let's do a commit check. Let's commit that. Alright, okay, run show route. We can see the routes here. So we've got 1.0, 2.0, 3.0, and 4.0. That means we should also be able to ping the directly connected addresses. Run ping 200.1.1.1, which we can. 2.1 and 3.1. 4.1. Yeah. So we have connectivity. Now, if I go back to the diagram, just to let you know, on this one, I have a loopback address. If I can do this here, of 143.0.0.1. So there's a loopback address here. Now for our router or any other devices to be able to reach that loopback address, we're going to need some kind of routing protocol. Now for the Juniper device to actually reach that loopback, you could use a static route or OSPF, something like this. And I have these for all of these addresses. So, and this one has .3, this one has .4.
Guys, I have a request from you. If you're enjoying the free content, I'm looking to increase my subscriber count to 4,000 subscribers by June. But I can only do that if you give me the Play Special. Do you want to know what the Play Special is? Press like and yeah, subscribe. Okay, back to the video.
So let's do the static routing to see about getting reachability to that from our router. And to do that, we need to go under our routing options. So top, and if I try to ping those at the moment, we didn't see them in the routing table, so we shouldn't be able to have reachability to them, yeah? They're nowhere in the routing table. So if I say run ping 143.0.0.1, no, there's no route to that host. So to get a route, I say edit, routing options, set a static route to get to the 143.0.0.0 network /24. Our next hop is going to be 200.1.1.1. Now for the sharp-eyed amongst you, you will see an issue here. If I go back to the diagram and I was to commit that, this loopback is also part of the 143.0.0.0 network, and this loopback here. So if I was to put this static route in, then this device will think to get to 143.0.0.2, I need to go through router 1. To get to 143.0.0.3, I also need to go through router 1. And to get to 143.0.0.4, I also need to go through R1. And they will never be able to get reachability to these networks, which we're going to display here. But there is a way around that. So let's commit that. So we should be able to get to 143.0.0.1. That should be pingable because it has a valid next hop address. But if I was to try and ping 143.0.0.2, there's no reachability, yeah? And there's another way we could actually check that. If I say run show forwarding table, okay, run show route forwarding table maybe. Run show route forwarding table. Let's see if we can match it on 143. Yeah. So we can see to get to the 143.0.0.0 network, we have to go to 200.1.1.1. Now, the way that we could get around this is its longest match. So at the moment, we have a /24, and any device is going to use a longer match. Now, when I say a longer match, the subnet length must be longer. So longer than a /24 would be like a /25, a /26. And the longest one, or the most exact route you could get, is a /32, which is a host route. And that's what I'm going to do for the other addresses. So if I say set static to get to the 143.0.0.2 network /32, we're going to use a next set static route. Set static route to get to the 143.0.0.2 /32 network. We're going to use the next hop of 200.1.2.1, 3.1 to get to the 3 network, and 4.1 to get to the 4 network. Let's commit check that and commit. Now if we do that same command again, run show route forwarding table, now we can see that there are 4 entries in the routing table, all with different next hop values and different next hop interfaces. So now we should be able to get reachability to all of those networks. So if I say run ping 143.0.0.3, we have reachability. And if we have a look in the routing table, run show route, we can see that we're using a static route here with a preference. The route preference is like administrative distance in other vendors' equipment, where a lower administrative distance means that that is a more preferred route. Now, static routes are pretty low as they're manually configured, so you find that that preference is 5. This star means that that is the active route, and that is the next hop address, and that is the interface that you're going out of. And the reason that's being chosen is because of the longest match. Now, if these static routes were to disappear, we wouldn't have reachability because this static route here says for the whole network go through R1, and obviously R1 doesn't have reachability to these other addresses. But I was only putting that in there to show you that the longest match rule applies. What you will need to know is, as I was saying previously, the preference values. So I'm going to put those on the screen now for you to have a look at. And we can see that a direct or a local route has a preference of 0. We know that a static route has a preference of 5. OSPF internal routes have a preference of 10. There were a couple of ISIS routes there. RIP routes, we have an aggregate route of 130, an OSPF external route of 150, ISIS level 1 external routes of 160, and level 2 external routes of 165, and BGP, both internal and external, have a preference value of 170. And there are a few values that we can look at. If, let's say if we were looking at an exact route, and they will show you a few things. So if I say run show route for, again, that route 143.0.0.3 exact, we see for this route, it's an IP version 4 route because it's using INET 0. It's using a static route to get there with a preference of 5, and the star means that this is the active route.
Question 1. Which device usually acts as a gateway? Question 2. Which routing protocol from the following will be preferred due to its lower route preference? Question 3. If the following are using the same protocol, which will be preferred and why? Question 4. Please look at the exhibit below. What does the star mean?